So up next is a BIM design automation expert. Onyema Udeze is the co-founder of Blaze Incorporated, the BIM consultancy, and also a founding director of the BIM Africa Initiative. So Onyema Udeze, welcome on board.
Thank you very much for the introduction. I believe you can all hear me.
Yes.
Yes.
We can hear you loud and clear. We got your slides on.
Okay.
Yeah, we just need to get out on Zoom.
Yeah, I'm talking from Outspace, so
awesome.
You should just help me to switch the slides.
Yeah, we got Zoom. Yeah, we got everybody on Zoom, so we're good to go. Let's run.
Okay, so like I've been introduced, I'll be talking about the BIM and design automation. But before I get started, I'll just give a brief intro about myself. So, as been mentioned, I'm a co-founder of Blaze Inc., which is a BIM consultancy and IT integrations outfit that is based in Nigeria. And I'm also one of the founding members and directors of BIM Africa Initiative, which is charged with BIM awareness and implementation across Africa. So I also specialize in creating a lot of content. So currently I'm an instructor at LinkedIn Learning. So I create a couple of online courses and also create courses for the academy, which is also an on-demand, online academy where you can purchase courses. And certification-wise, I use Revit mostly. I'm a certified professional for Revit, architectural, mechanical, and electrical disciplines. So I've used Revit for quite over 10 years now. So next slide, please. Yeah, so as architects, we all know that design is a creative endeavor that taps into our innate expressive capabilities as designers. I mean, through our designs, we've been able to reshape the world around us. I mean, when you visit any part of the world today, one of the things that stick most to your memory is the architectural and engineering designs that complement the natural elements in various parts of the world. So as creatives, our designs most times tend to be limited by our experience, our exposure, and our natural talents as designers. But the world around us today is changing rapidly. So these changes tend to pose new challenges to us designers, and the more complex our design problems get, the more we need new tools and technologies to manage these complexities to deliver even more innovative solutions to the world today. And also, when you look at the design, beyond the creative aspects of design, there are so many redundant and repetitive tasks. When you're talking about things like project documentation, detailing, annotation tasks, these things can be quite tedious and repetitive and even mundane and very boring at times. So in recent years, the emergence of artificial intelligence has brought up new ways to iterate the design process, leveraging technology. So instead of just simplifying common tasks, today you have algorithms that can now figure out how to solve very complex problems on their own. So then that is what I'm going to be focusing on in this presentation. So basically, I will explore certain levels of design automation and also talk about various tools of computational generative design and the role of BI and business information modeling in all of this. So next slide, please. So before I get started, what exactly is design automation? To define that, I also first of all talk about automation itself. So if you Google automation today on the internet, you come across so many definitions of automation, but there's a popular definition by IBM, and it says that automation is a term for technology applications where human input is minimized. So this includes such things as business automation, IT automation, personal applications such as home automation, and so many other forms of automation. But then basic automation is programmed to perform repetitive tasks so that human beings don't have to get involved. So that's automation. Talking about design automation, this basically entails using software programs to perform repetitive and mundane tasks during the design process. I mean, design in the build sector, when you look at it, see that it has progressed over the years from manual hand drafting to the based computer-aided design, which is CAD. I mean, we have moved past CAD today, and today we're talking about 3D-based BI and business information modeling. But then when you come to the world of 3D modeling, you see that there are basically two broad classifications of tools. You have the generic modeling tools, and you also have the parametric modeling tools. So generic modeling tools basically is used for conceptualization and early design iterations. I mean, popular tools here are such tools as Rhino and SketchUp. Those are generic modeling tools. And then on the other hand, you have parametric modeling tools, which are mostly used for more detailed design and construction documentation. I mean, here you start talking about such tools as Revit and ArchiCAD. So then let's look at the levels of design automation that we have. So for the sake of time, I've been able to break this down into 3 major categories, or 3 major levels of design automation. And the first level of design automation is basically parametric modeling. I mean, the underlying principle behind parametric modeling is being able to use parameters to control the behavior and appearances of objects 3D model of, say, building. You can use parameters to control the various objects you have in that. A typical example that we all know is such things as BIM objects. I mean, when you look at a BIM object today, let's say, for example, a Revit family. A lot of us today use Revit for our designs. When you look at a Revit family, you see that you can use parameters to change the size of these objects in various axes, X, Y, and Z axis. You can use conditional logics to control the visibility and the behavior of the various parts of these objects. You can even use formulas to control arrays, and then these arrays can also control the number of elements as the object dimensions change, and the materials applied to these objects can be changed with the use of parameters as well. You can even change the types and the families of these objects with the click of a button, and each of these types have their own unique parameters. You can even use custom and shared parameters to meet your particular design needs. So all this is the beauty of parametric modeling workflow when you compare it to generic modeling workflow. And this seems commonplace today just because we have got quite used to all these tools. But you can imagine what life would be like if you have to model every permutation of the size, the material, and the possibility of these objects during your designs. So, but parametric modeling, as beautiful as it is, it has one major limitation, and that is because it relies mostly on the out-of-the-box features of these tools. I mean, if you have to rely solely on Revit, for example, to do your designs, then you are constrained in a lot of ways. And that is where the second level of design automation comes in, and that is computational design. So computational design basically stretches beyond the out-of-the-box features of 3D modeling tools. And this entails using computers and mathematical operations to manipulate data to generate geometries and objects. I mean, one of the popular applications of computational design today is visual programming. Okay, visual programming basically is a type of programming language that lets human beings to describe processes using illustrations. I mean, where if you are using a text-based programming language, you have to think like a computer by typing in codes and all that. But when you're using a visual programming software, this kind of makes the process, it puts it in a way that human beings can understand. And with the use of these tools, you're basically programming, but they're not writing any code. That's basically how visual programming works. And this is a good starting point for beginners that are moving into the world of computational design. And one of the very first visual programming languages to enter the architectural space is Grasshopper, which is basically a plugin for. I mean, Grasshopper uses a set of building blocks called components, and these represent individual operations. And this can be such things as mathematical operations such as addition and multiplication. And then these components can then be connected or linked to each other. Basically, that's how the whole Grasshopper interface or any visual programming software, that's how it basically operates. I mean, with the use of Grasshopper, such tools as Rhino can become parametric by making use of the computational features of the Rhino. But they also have another popular visual programming software called Dynamo, which is from Autodesk. So Dynamo basically connects to Revit and several other Autodesk software. And its usage spans the entire design and delivery stages of projects. But these tools are mostly tailored more towards design conceptualization, which is conceptual design. But beyond design conceptualization, you can also use computational design for design automation. And that is one of the most popular aspects of computational design today. So this actually, a lot of time has to do with writing scripts to automate repetitive and mundane tasks within the 3D modeling tools such as Revit. I mean, you can use it to automate such tasks as annotation, documentation, and presentation, like I talked earlier at the beginning of the presentation. And a good example here is maybe tagging elements of BIM model. Imagine the time it will take you to tag all the rules, all the rooms, all the doors, windows in your project. You can write scripts that can help you to automate some of these tasks using Dynamo Player. I mean, within Revit, the Dynamo Player plugin, it helps you to execute Dynamo scripts for Revit without having to access the Dynamo interface. So that is one of the most popular applications of design automation today. And today, companies are beginning to write scripts that help them to automate all the redundant tasks to speed up their documentation flow. Right, so that is one of the aspects of it. I mean, today you can also have third-party design automation tools that come mostly as plugins to these BIM modeling tools. For example, if you visit Autodesk App Store today, you can just search for productivity tools, and from there you can see a lot of plugins that can also use to automate a whole lot of your design. So that's the second level of design automation, and that is computational design. The third level now is what is called generative design. So generative design basically is a new design approach where you work with a set of tools to describe a design problem to the computer, and then the computer generates many possible solutions and help you to find the best one. So this way, this kind of enables the designer to think outside of the box, because it exposes you to much more solutions that you cannot get using the traditional design process. And this it even does in a very short period of time. So that is basically, instead of working through the traditional approach, when it comes to generative design, the computer is helping you to think beyond the box. So basically, when you're talking about generative design, there are three major stages or three major steps. And the first step of the generative design process is to create a generative model. And this will help you to create many possible variations of your design within the constraints of your design problem. So you have to create a generative model, you give it the constraints, and with this, you now move to the second stage, which is now when you begin to translate your design goals into objective metrics. So there are two conditions there. These metrics, they must be quantifiable in the sense that you must be able to express them numerically. And secondly, they must be computable, meaning that their values can be set by the design options. So that's the second step. You are translating your goals into metrics. And then these priorities for the metrics also need to be defined either as objectives or as constraints. So these are basically you are telling the computer how you want them to translate your goals. And then after you've told the computer how to evaluate each of these solutions in generative model, then the final step is now to optimize algorithm. So basically you make use of optimization algorithms to explore the various options, and then the computer will help you to find the best solution. And then the results of this can now be visualized. They can make use of different visualization tools. You have scatter plots, you have parallel coordination charts. So those are the three major steps when it comes to generative modeling. You have the creating the BIM model or the model that will serve as your design, and then you have to optimize it. And then with the growing popularity of visual programming languages today, such as Grasshopper and Dynamo, you see that simulation tools are also being developed as part of these tools as plugins. So they incorporated directly within the tools as plugins. And then when it comes to optimization, you also have inbuilt tools. For example, in Grasshopper, it comes with what is called Galapagos, which helps to optimize your design directly within Grasshopper. You don't need to go to another software for you to optimize your BIM models. And then also, when it comes to Dynamo, you have the refinery plugin that also helps for these optimizations. And also, within other modeling software, for example, Rev 2021 upwards today come with what is called the generative design primer. So this is based also on the refinery beta, and this is currently available to Autodesk AC collection subscribers. So basically today you see that these tools are now being incorporated within the model. So with this, can now carry out a generative design without having to explore so many other software. So these are the three levels of design automation. I've talked about parametric modeling, computational modeling, and then I've talked about generative design. So what is now the role of BIM in all of this? Right? So as creatives, you see that it's very easy for us to get lost with design iterations, especially as young professionals. So it's very important that the guiding staff for the whole process of parametric, computational, and generative design should be on producing more innovative and human-centric designs for increasingly complex work. So it's not just about creating very fancy and complex stuff on the screen. This should actually be tailored towards creating very human-centric problems that will help to solve our problems in the world today, right? And through a BIM workflow, basically, can co-design and communicate in real time with other stakeholders on the project, including the end users and the clients. Thanks to cloud-based collaboration platforms today, such as BIMX, Autodesk Construction Cloud, Procore, Trimble Connect, and so much more. These platforms, they serve as common data environment on our projects today. And then leveraging parametric, computational, and generative designs, we're not only creating better designs in a much faster way, but we're also creating information-rich models. And this makes the construction and the management of these facilities much more seamless. So that is where BIM comes into all this process. It kind of helps to unify all the stakeholders on a project. So in conclusion, I would say that the concept of design automation, it tends to paint a picture of a future where artificial intelligence and algorithms will replace human beings entirely and take over the design process. But that is not true. In the course of this presentation, it's obvious that it will take human beings to set up the metrics for the design simulations. And it also takes human beings to include the objectives and the constraints during the generative design process. For example, to also take human beings to interpret the outcomes of the optimizations and also improve on these outcomes. And finally, it will also take human beings to write the automation scripts, build on them, and improve the plugins over time, right? So the whole idea of design automation is actually to complement architects and designers by leveraging intelligent tools to take care of the repetitive and the redundant tasks. And in the process, it helps to unleash the creative designs beyond the latent creative potentials of the human mind. So that is the whole idea of design automation. It's actually a tool to help to complement our talents as designers, right? So in essence, designers should not shy away from the whole tool and the technology of generative design and design automation. Instead, they should actually embrace these tools to make their life easier. So in conclusion, I would say that over time, the role of human beings in design, it will likely change from a traditional design method to a higher role of human beings now telling the computer what to do and then guiding the computer all the way. Next slide, please. Yeah, so before I round up, I'd just like to talk a little bit about Blaze Academy. So Blaze Academy is basically an online academy, a platform where you can purchase or you can access so many online courses. And recently, we've been able to create some membership packages. And through these membership packages, we'll be able to access all the courses on the platform. So currently, we have two packages. We have a package for professionals and we have a package for students. For the professional members, with as low as $9 per month, you can be able to access all the courses on the platform. So we create courses for thought leaders in the industry. And also for students, we have a very subsidized package whereby with $20, you can access all these courses on the platform throughout the year. So at the moment, we also create a lot of activities like how I mentioned earlier, live sessions, we create podcasts, and we also communicate with other stakeholders in the industry over time. And the whole idea of this is to help to improve our industry. So thank you very much for the time. If you have any question at this point, I'll be willing to answer.